Welcome to The Explainer. Today we're going to trace the wild evolution of software design. We've gone from drawing up elegant blueprints for a single application to basically becoming city planners for these huge, sprawling data systems we rely on every day. So let's dive in. So let's rewind to the mid-90s. This quote pretty much nails the big problem everyone was facing. Developers were really struggling with this timeless question, right? How on earth do you manage all this complexity and build stuff that you can actually reuse, stuff that's flexible and, built to last? And then came this landmark book, Design Patterns. It was written by these four authors who became legendary, the Gang of Four. And what they offered was just brilliant. It wasn't some newfangled programming language or a flashy tool. Nope. It was something way more fundamental. They gave us a shared vocabulary, a set of elegant, reusable blueprints for tackling the problems that kept popping up over and over again. Okay, so to really get what this means, let's look at a classic blueprint, the decorator pattern. The idea behind it is so simple, but wow, is it powerful. It basically lets you wrap an object with new abilities all on the fly. Think about adding a border to a window, or maybe adding compression to a file you're sending. And you can do all that without ever touching the original object's code. Pretty cool, right? All right, I know what you're thinking. This diagram looks a little intense. But trust me, the core idea is actually super simple. The whole magic trick here is that the decorator is designed to look exactly like the component it's wrapping. So you can keep adding new features. Think of them like superpowers. And to everything else in the system, it looks like nothing has changed. That new functionality, it's totally invisible. And this is what it looks like in actual code. It's like those Russian nesting dolls. You start with a core, a basic file stream, then, boom, you wrap it in a layer that handles text encoding. But we're not done. Then you wrap that in another layer to add compression. See, each layer adds a new job, one on top of the other. But the original file stream at the center, it stays simple. It's such an elegant and flexible way to build things. So if you boil it all down, a lot of these patterns come back to this one core principle. This one, right here, program to an interface, not an implementation. See, by relying on these abstract contracts, these interfaces, instead of locking yourself into specific, concrete classes, developers could build systems that were, they were loosely coupled. You could literally swap out one part for another, and the whole system wouldn't fall apart. And that's the holy grail of flexible, maintainable design. But then, everything started to change. The digital world just exploded, right? And with it, the kinds of problems engineers had to solve started to shift dramatically. Those beautiful blueprints for designing a single perfect building, they were still super valuable, don't get me wrong, but a new, much, much, much bigger challenge was right around the corner. And this really sums it up. The problem wasn't about building the perfect, self-contained house anymore. Suddenly, it was about orchestrating this sprawling, chaotic digital city. We're talking millions of users, millions of applications, all connected by this insane river of data flowing between everything. The old blueprints, they weren't useless, not at all, but they just weren't enough to tackle this new scale. Okay, so that brings us to the modern manual for this new world. We're talking about Martin Kleppin's Designing Data-Intensive Applications. You can really think of this book as the next chapter in our story. It represents that huge shift in thinking away from those object-oriented blueprints and toward the principles of city planning, but for these massive interconnected data systems. So instead of obsessing over how classes talk to each other inside one program, this new way of thinking zooms way, way out. It focuses on the fundamental pillars of our digital city, things like reliability, scalability, maintainability. In plain English, that means asking questions like, how do we keep this thing running when parts of it inevitably break? How are we going to handle 1 million new users signing up tomorrow? And maybe most importantly, how do we keep it simple enough that the next wave of engineers can actually understand it and build on it? And here's a perfect example of this new kind of complexity. Modern systems have to wear two totally different hats at the same time. On one hand, they have to be a bustling marketplace, processing millions of tiny transactions every single second, someone buying a coffee, liking a photo. But on the other hand, they also have to be a massive city archive, letting us dig through mountains of historical data to find patterns and insights. And let me tell you, those two jobs are fundamentally different. This right here, this is a whole new kind of headache that you only get at this massive scale. In a distributed digital city, even something as simple as right now gets, weird. Look at this. User 2 sees a new email pop up, but their unread counter hasn't caught up yet. They're literally seeing a piece of the future, a kind of ghost in the machine, just because information takes time to travel across the network. This isn't a blueprint problem anymore, folks. This is a city planning problem. So, okay, we've gone from focusing on a single perfectly crafted object to this entire ecosystem of data. The scale has just changed beyond recognition. So does that mean we threw all those old design principles out the window? Absolutely not. I mean, this comparison really tells the whole story, doesn't it? On the left, you've got a classic design pattern. Its whole job is to organize classes inside a single program. It's an internal blueprint. But then you look to the right. That's today's world, a massive system that's fighting with issues like timing and consistency across a global network. The complexity isn't just inside the code anymore. It's moved to the space between all the different systems. And yet, those core ideas are more important now than they have ever been. Take the classic adapter pattern, for example. Its original job was to get two incompatible parts inside one program to talk to each other. Well, guess what? We use that exact same principle today, but now we're using it to connect huge, complex systems across the globe. See, the fundamental goal is exactly the same: manage complexity by drawing clean, well-defined lines in the sand. So this whole journey from blueprints to city planning really shows us something profound. Our tools, the scale of our problems, that stuff is always going to change. It's inevitable. But that fundamental search for elegant, strong, and maintainable design, that's timeless. Which leaves us with the big question, right? What are the architectural principles we're going to need for the next generation of systems? What will that map even look like?